Again, we are doing R7 rational expressions. Interrupt me if you have questions about anything. All right, rational means fractions. I know I've said it like every class, but this is the most challenging unit for me because it's so scattered and it's so much content. So much content and doesn't necessarily, it just builds on the, if it builds on the one before it, it builds really quickly on the one before it. And I don't think it's very easy. So I want you to know that it will get better. All right. So a rational expression is a fractional, I guess would be better to say fractional expression. But if you see the word rational, it means fractions. What we are doing with these trinomials or binomials is we are going to factor them and then we are going to reduce them to lowest terms, because after you factor something, you have a bunch of factors in a list and then you can cancel out, right? If you have, let's say I have 10 over 4, good? And I want to put that into its simplest form or lowest terms. What I can do is I can say, however you want to do it. If you can just think I can divide 10 by 2 and I can divide 4 by 2, that's fine. Or you can say the factors of 10 are 2 and 5. The factors of 4 are 2 and 2. I almost wrote 4, that's foolish. And then because they are being multiplied, you can cancel out anything that is common to the numerator and the denominator. Good. So 10 over 4 is actually the same as 5 over 2. That's what they mean by lowest terms. So we're making factors and then we're canceling out any factors that are common to the numerator and denominator. Good. All right, let's get started. So this is factoring practice and just getting comfortable with fractions is what I would call this. Here we have x squared plus 6x plus 9. This is a perfect square trinomial. So we can look at it as a perfect square trinomial. There's a short video on my YouTube channel on perfect square trinomials, or you can just do it the way we've always done trinomials, which is A, B, C, right? So in this case, A is 1, B is 6, C is 9. We need to find two terms that multiply to equal 9 and that add to equal 6. So we think about what are the factors of 9? 1 and 9 or 3 and 3. Good. Which of those add to a positive 6? You could also say -1, -9, -3, -3, right? Because those multiply together to get a positive 9. But if I want to add to 6, it's only going to be 3 plus 3 is 6, right? So what that means is, since A is 1, x squared only factors to x times x, except that it factors to x squared and 1, but we would never use that, don't worry. So if you see x squared, you can just automatically write x times x. And then our other two terms are going to be a positive 3 and a positive 3. Good. Down here on the bottom, I have x squared plus 5x plus 6. So again, we want it to multiply to equal c, which is 6, add to equal 5. Multiples of 6 are 1 and 6. Because it's positive 5, I'm just going to pick the positive factors of 6, 1 and 6, or 2 and 3, right? 2 and 3 add to 5. Sorry, sometimes I circle it, sometimes I draw an arrow. I know I did that last class too. Not clear. So again, because A is 1, we just say x times x. And then our second term in the binomial is going to be our two factors of c. The two factors of c are a positive 2 and a positive 3. So this is fully, I apologize, you couldn't see that. This is fully factored. Any questions? So that's just what we were doing last class. Now, canceling. If it's exactly the same on the top and the bottom, you can cancel it. So I have 2x plus 3s, which you can write as x plus 3 squared, right? But because we want to cancel out what we can, we're going to write them out as x plus 3 times x plus 3. And then I cancel out the x plus 3 in the numerator and the x plus 3 in the denominator. And my final answer is x plus 3 over x plus 2. Is it clear that we cannot cancel out those x's? We cannot cancel out those x's because those are being added to something else. So this is one factor, right? And this is one factor. So you can only cancel out things that are multiplied together. We're only canceling multiples. So if there is a multiplication sign between them, that is its own thing and you can cancel it. If there's a plus sign between it, I cannot just cancel out those x's because that is not multiplication, that is addition or subtraction, right? All right, the next one is the same, right? So perfect square trinomials mean the first term and the third term are both perfect squares. So x squared becomes x if I were to square it, right? And then 4 becomes 2. Just like 9 became 3, so it became 3 and 3. X squared became x, so it became x plus 3 times x plus 3. So here we have, we're going to factor the trinomial into 2 binomials. X squared becomes x, and x. 4 becomes 2 times 2. But you have to make sure that that middle term is the same as 2 times 2 times x. Or we just do it the long way. And again, there's a video on that called Perfect Square Trinomial. Oh, because someone pointed out that I had not taught that. So if you don't know perfect square trinomials, you just say A is 1, B is 4, and C is 4. So that means they need something that multiplies to equal 4 and adds to equal 4. So the only choice there is positive 2 and 2, right? So that's how I got those. Both positives. They multiply to 4 and they add to 4. Down here, I have x squared minus 4. This is the difference of 2 squares, okay? So we did go over that. The difference of 2 squares means that I can take the square root of x squared and the square root of 4, not negative 4, positive 4. The square root of 4 is 2. The square root of x squared is x, right? The difference of 2 squares means I take those and I put them into 2 binomials, and we took notes on this, I think it was the last class. One gets added, the 2 get added together, the other one, the 2 are subtracted. One is taken from the other. Difference of 2 squares. And I would just write that on my note card. Just a squared minus b squared becomes a plus b times a minus b. Good. So a squared was x squared, so a itself is x. B squared was 4, so b itself is 2. That's how we got those. And then we just look at it and we think x plus 2 and x plus 2 can cancel out. So our final answer is x plus 2 over x minus 2. And you can add parentheses, include the parentheses or not, it does not matter. The third one is getting a little busy, so I'll rewrite it down here. X cubed minus 27. Now I said cubed. I know that the cubed root of x cubed is x, right? Is there a perfect cube of 27? There is. It is the number 3. Good. So the difference of 2 cubes, again, it would just be something that I would write in my notes, means that, so that one's A and that one's B, right? A is X, B is 3. So the difference of 2 cubes formula means that it becomes A minus B times A squared plus AB plus B squared. And what it was before was A cubed minus B cubed. Is that all right? Now I know what A and B are, so I can translate that. A becomes X, so it's now X minus B is 3, X minus 3, X squared plus 3X plus 3 squared. I'm just going to immediately write 9, okay? And that's just a formula that you can write in your notes. So I'll put that here. X cubed minus 27 becomes the quantity X minus 3 times the quantity X cubed plus 3X plus 9. That is a trinomial, right? Can I factor this trinomial? Oh, sorry, that's not a 3. I apologize. Super confusing. What's a 2? Just from copying it from there to there, I changed the amount. All right, so that's a trinomial, X cubed plus 3X plus 9. I just want to show you that this is a prime trinomial, okay? There's nothing I can do to simplify this. A is 1, B is 3, C is 9. Are there any 2 numbers that multiply to equal 9 and that add to equal a positive 3? The factors of 9 are 1 and 9, -1 and -9, 3 and 3, -3 and -3. None of those add up to a positive 3. So this, even though it looks like these over here and the things that we have factored, we can't factor this. This is called prime. Okay. And then down here, we have X cubed minus 3X squared. I know that X cubed, I can take the third root of that, right? And it becomes X. But if I put 3X squared and I try to put it under a third radical, a radical 3, there is no perfect cube of it, okay? So this cannot be the difference of 2 cubes because this is not a perfect cube. This is a perfect cube, this is a perfect cube, this is a perfect cube, which means when I take the third root, I get a whole number. Or a variable. But this I cannot. So what is the only thing I can do to factor X squared minus 3X, or X cubed minus 3X squared? There's only one thing I can do. I can divide them both by X cubed, right? That means I take out the X cubed, X to the third divided by X squared is just X, -3X squared divided by X squared is just -3. Now I can cancel X minus 3 because it's in the top and the bottom. Now I have, I'm going to write it correctly this time, X squared plus 3X plus 9 over X squared, and we are calling that prime. Prime means I cannot factor it. Even though I have an X squared and an X squared, this X squared is being added to the 3X and the 9, so I cannot separate it. last one on this page, I'll start down here. It's a little bit challenging. So I have x minus x squared over x squared plus x minus 2. Sorry, couldn't even see it. So x minus x squared, again, I don't have a perfect square. I certainly don't have a perfect cube, but I do see that these are in the wrong order. Okay, you should always have them in descending order or standard form. So I'm going to change it to negative x squared plus x. It's not going to change the correctness of your answer. Good. All right, so all I can do to negative x squared plus x is take out 1x, right? I can divide negative x squared by x and x by x. So all I'm doing there is so that I can call it x. Negative x squared divided by x will just give me negative x. X divided by x is a positive 1. So whatever is common to both of them, whatever I can divide them both by, I put out front. I know that looks scary because I just made a bunch of fractions, but I just wanted to represent that I was dividing it. Good. Just like up here, we divided by x squared. And then on the bottom, we have x squared plus x minus 2. That's in standard form. And I can try to use this system to find the 2 factors. I know it's x squared, so I know it can become x times x. And if you've had a lot of experience factoring in other classes, you might be able to just do this really quickly in your head, right? So we need it to multiply to equal -2, and we need it to add to equal 1, because -2 is our C and 1 is our B. So the factors of -2 are 1 and -2, or -1 and 2. Which one would add to 1? -1 and 2. So now we have x minus 1, x plus 2. And if you are just sitting there thinking -2 is only -1 and 2, or 1 and -2, right? You could just make a little list like that if you wanted, if you know it's a small number or a prime number, or if you're really good at numbers in your head. All right, so now I have x times the quantity -x plus 1 divided by x minus 1, x plus 2. Do you see any common factors? Anything I can cancel? Not the x plus 2, right? This is -x plus 1, and this is x minus 1. They are almost the same. The only difference is the signs, right? This is a -x when this is a positive x. This is a positive 1 when this is a -1. So if it's 2 terms, or however many terms it is, in this case it's 2 terms, they are the same terms, and the signs are completely opposite in both cases. Negative is positive, positive is negative. What you can do is you can multiply either, does not matter which one, either the top or the bottom by -1. You know what? It's simpler to explain it as dividing it by -1. So I'm going to take x times -x plus 1, and I'm going to divide it all by -1. This stays the same, so this is still x minus 1 times x plus 2. And you can think of it as multiplying by -1 too. It doesn't change anything, right? Multiplying by 1 and dividing by 1 is the same thing. But basically, x divided by -1 becomes -x. That whole situation, -x divided by -1 becomes a positive x. 1 divided by -1 becomes a -1. So I took everything and I changed all 3 of the signs so that it would match this down here. This is the two factors. So when you have two terms that are almost the same and both terms are the opposite of the one on the other side of the division bar, you can multiply or divide either side by -1. Now, if you notice that negative x, that x becomes a negative x, so that's holding the -1, okay? So the -1 still exists. We just moved it from over here to here. So it was there, now it's here, and now I can cancel these, and my final answer is -x over x plus 2, which is the same as negative x over x plus 2, which is why it doesn't matter if you use the bottom or the top to divide by -1. You do this when they look alike, but with opposite signs. So that is just simplifying rational or fractional expressions. Now we're going to go on to multiplying fractional expressions, okay? It says perform the indicated operation and simplify the result. Leave your answer in factored form. So when you're multiplying fractions, if I had the fraction a over b times c over d, right? It becomes, I just go straight across. A times c is ac, b times d is bd. So here, I just have this trinomial times this binomial over this binomial times this trinomial. But before I multiply it together and make it bigger, I'm going to factor it. So x squared minus 4x plus 4. If it's x squared, I know I can just turn it into x times x. And if you know perfect trinomials, perfect square trinomials, you know what that is. If not, you can say it needs to multiply to equal c, add to equal b. So it's going to multiply to equal a positive 4, add to equal a negative 4. What are our factors that need to add to a negative sign? So it's either -1 and -4 multiply to a positive 4, or -2, -2 multiply to a -2, -4. Which ones add to -4? -2 times -2. So it's x minus 2 times x minus 2. That's the simplest form of that trinomial. On the bottom, we have x cubed plus x. All I can do here is take out a common factor, we could say. If it's x, the most x's I can take out is 1x. So I'm just going to divide x cubed and x by x. That means that x goes out here. X cubed divided by x is x squared. X divided by x is just 1. Now you'll notice there's nothing I can simplify, nothing I can cancel out, right? But this is being multiplied by this. Multiplication, basically, all it means, right, is we're just extending that line. AB times CD means AC over BD. You're just making that line longer. 3x cubed plus 3. 3 is not a perfect square. So I cannot turn that into two binomials, but if I have 3x squared plus 3, is there anything I can divide them both by? I can divide them both by 3, right? So that means that becomes 3. 3x squared divided by 3 just becomes x squared. Positive 3 divided by 3 becomes a positive 1. Here again is something that looks more like this. The a is 1, so it's just x squared. X squared can only become x times x. It needs to multiply to equal c, add to equal b. So it's going to multiply to equal -3. No, sorry, add to equal -3. Multiply to equal 2, add to equal -3. So this is interesting. We need to multiply to be a positive number, add to be a negative number. That means it has to be our only options even to make the list are negative factors of 2. So only -2 and -1. Luckily, -2 and -1 add to -3, right? So it's x minus 1, x minus 2. So what we've done is we've taken this, turned it into that, this is that, this is that, this is that. So now, and we're multiplying it, so I can write them all on one line. X minus 2 squared, or x minus 2 times x minus 2, times 3 times x squared plus 1. On the bottom, we have x times x squared plus 1 times x minus 1 times x minus 2. Now you just x minus 2 on the top, there's an x minus 2 on the bottom. There's not a second one, there's no 3, but there is an x squared plus 1. So you eliminate what you can, and then it's also makes sense to me to like put it in a different order. So 3 times x minus 2 over x times x minus 1. And you leave your answer in factored form. So here, because of that multiplication sign, we just made it so that all the terms can cancel across. This canceled with this canceled with this. And we put everything else together. Questions? All right, now we are adding. Perform the indicator operation, simplify the result, leave it in factored form. When you're adding or subtracting a fraction, you need a common denominator. So again, that's the numerator, that's the denominator. You need your denominators to be the same. Luckily, these denominators are the same. So we can just write that denominator once, 2x minus 3. And what we have on top is, I make a list, 2x squared plus 6x plus 3x plus 4. Now, all I can do is combine like terms. Positive 6 and positive 3 become 9x and 4 over 2x minus 3. Two x squared plus 9x plus 4. That's a harder one. So you have, it needs to multiply to equal a times c, and it needs to add to equal 9. A times c is 2 times 4, which is 8, right? So it needs to multiply to equal 8, add to equal 9. Multiples of 8 that would equal a positive, am I saying that wrong? I'm not, right? Multiply to equal a times c, add to equal b. All right, sorry, brain fart. All right, multiples of 8 that would add to 9, just 8 and 1, right? Okay, so we have 2x squared plus 9x plus 4. The 9 becomes x and 8x, right? Those are both positive. So we have positive 1 and positive 8. Doesn't matter what order you put it in. So we have 2x squared plus x plus 8x plus 4. Now I have to do, what is it? Factoring by grouping. So my first group is 2x squared and x. Divide them both by x. 2x squared divided by x is just 2x. X divided by x is a 1. The other side, positive 8x plus 4, so it has to be a positive. I can divide them both by 4, right? 8x divided by 4 is 2, sorry. Not supposed to put that here, I'm supposed to put a 4 here. 8x divided by 4 is 2x. 4 divided by 4 is 1. So that becomes 2x plus 1 is what we're taking out, and we are left with x plus 4. That is the long way to do that. You might just see it, right? You might just see that the only factors of 2x squared are 2x and x, and the best factors of, or the easiest factorable way to get 9 is to multiply 4 times 2 to get 8, and then add 1. Anyway, that becomes 2x plus 1 times x plus 4 over 2x minus 3. So if you put this answer into my math lab and it says it's wrong, you might want to make sure you can't factor that a little bit further and eliminate one of them. But in this case, we can't. It was just also, you should know that you can keep factoring that. Good. This just has to do with the domain, which we'll cover later, but it's basically like this can't exist. If x is 3 over 2, then that would give us a 0 for our denominator, and we know that a 0 in the denominator is undefined. Another. All right. Second one is 6 over x minus 1 plus x over 1 minus x. Are these common denominators? X minus 1, 1 minus x. Well, first let's put it in order. X minus 1, that's already in descending order of exponents. Let's change this to negative x plus 1. So we see we have the same problem as before, where one of these is the wrong sign, essentially, right? And so what we're doing is divide by negative 1, divide by negative 1. Anything I do to the bottom, I have to do to the top. Six over x minus 1 stays the same, plus. So now x divided by negative 1 is now a negative x. And then negative x divided by negative 1 is a positive x. 1 divided by negative 1 is a negative 1. So now I have a common denominator. So if I wanted this to be if I wanted this to be common with this, I needed to make my x a negative x. So I just made all of it negative, right? It's a longer way to do it, but I made all of it negative. 6 minus x is what I have on the bottom, and I keep the denominator x minus 1. My answers can't be negative 1, and my answers can't be 1. Or my answer x can't be. That's just the domain. So this is 6 minus x over x minus 1. And it doesn't matter if you had made it negative x minus 1, or sorry, negative x plus 1 or x minus 1. It just would have changed the signs up here. Next one is 3x over x minus 4 plus 2x over x plus 3. Definitely not common denominators, right? So what we need to do is take this one, multiply it by this one. So our common denominator is just going to be x minus 4 times x plus 3. So I should make it plus 3. Good. Anything I do to the bottom, I have to do to the top. Here, if I want my common denominator to be x plus 3 times x minus 4, then I need to multiply by x minus 4. 3x times x plus 3 over, or sorry, let's just say plus 2x times x minus 4 over x minus 4 times x plus 3. And I know I switched the order of those, sorry. Not the way I had it written before. Good. Before I can start eliminating, because of this plus sign, I need to distribute the 3x and the 2x. Okay, that's because of that plus sign. I can't just say this cancels this and this cancels this, and I'm back to what I had. Okay, that would be wrong. Instead, I'm going to distribute. Use a different color. 3x times x becomes 3x squared. 3x times positive 3 is 9x. 2x times x is 2x squared. 2x times a negative 4 is minus 8x. Now I can combine like terms. 3x squared and 2x squared become 5x squared. Positive 9x minus 8x becomes plus x. Over x minus 4 times x plus 3. 5x squared plus x can become, sorry, I can divide them both by x, and it's x times 5x plus 1 over x minus 4 times x plus 3. That was just me starting to write 5 by mistake. So that's our final answer for that fourth one. And then for the third one. And for the fourth one, again, I'm going to cross multiply. So I'm going to multiply x squared minus 1 times 1, and then x squared minus 1 times x. I'm going to multiply this x times this x, and this x squared minus 1 times x. So we have x over x squared minus 1 over x. I need to cross multiply, so I'm going to multiply this fraction by x on the top and the bottom. I'm going to multiply this fraction by x squared minus 1. Good. So this is now x squared minus 1 times x squared minus 1, but it's all minus. Okay, so it has to be minus x squared plus 1. Is that okay? Because I'm multiplying it by a negative 1, so I change that sign and that sign because of the parentheses. And then on the bottom, I just have x times x squared minus 1. X squared minus x squared, those cancel out, and I just have 1 over x times x squared minus 1. Good. All right. How much time do we have? 5 minutes. Do you want to just start with this next class? Is that okay? Looks like a little much for 5 minutes. All right. I will start with the end of this unit, and I can change the due date if it becomes a problem. Okay. You guys have a wonderful Monday, and I will see you on Wednesday.